Welcome everyone. Now we'll present the summary of Corrosion Control Document or CCD systems based on API 970 guidance document. Please be informed that this summary is intended to simplify the content based on the presenter's interpretation. Agenda 1. Scope. Scope number A. What is a Corrosion Control Document or CCD? Is a system or repository that contains all key information about corrosion and material damage risks in a specific process unit. It helps to identify damage mechanisms, how corrosion can occur, factors influencing corrosion, and actions to reduce risk of leaks or failures. Scope number B. The purpose of Corrosion Control Document or CCD development is to support mechanical integrity programs by improving inspection planning and risk management. They integrate with other programs like Management of Change or MOC, Process Hazard Analysis or PHA, Risk-Based Inspection or RBI, and Integrity Operating Windows or IOWs. Number C. Scope of Corrosion Control Document or CCD Recommended Practice. This guideline covers what CCDs are in related terms, how to create, maintain, and update CCDs, data needed for CCDs, types of CCDs for different process units, how to integrate CCDs with other risk management systems, and roles, responsibilities, and knowledge transfer. Scope number D. What equipment is typically covered? They are pressure vessels, process piping, storage tanks, atmospheric and pressurized, process heaters, pressurized parts, heat exchangers, and optional for instruments, relief devices, internals, pumps, valves, stacks, electrical, and structural systems. Number E. Key points of Corrosion Control Document or CCD. CCDs are not always standalone documents, they can be part of existing systems. The level of detail depends on the unit's complexity and risk. CCDs can serve as a foundation for RBI and IOW programs. Agenda 2. Introduction. Number A. A CCD is a living repository that serves as a damage control source for all integrity stakeholders. It contains or links to key process info, unit-specific damage mechanisms, materials of construction, inspection history, lessons learned, and records of process changes. The CCD forms the basis for inspection plans, IOWs, RBI strategies, and maintenance planning. Introduction. Number B. About key components of CCD systems. A CCD typically includes, number 1 is, unit description containing the purpose, operation, construction date, major revamps. Number 2 is, operating conditions, temperature, pressure, key parameters. Number 3 is, process stream compositions. Number 4 is, equipment and circuits with materials of construction. Number 5 is, process flow diagram or PFD and corrosion management diagram or CMD. Number 6 is, damage mechanism management, prevention, detection, monitoring, inspection methods. Record locations. Number 7 is, critical points, including, injection or mix points, dead legs, and alloy specification breaks and bimetallic welds. Number 8 is, operating concerns, excursions, startup and or shutdown, auxiliary processes. Number 9 is, maintenance concerns, special procedures, welding precautions. Number 10 is, failure history, significant failures, repairs, replacements. Number 11 is, lessons learned, from company or industry. Number 12 is, recommended actions from reviews. And number 13 is, IOW limits and actions for exceedances. This CCD systems has a target audience. They are, primary users, corrosion and or materials engineering and inspection teams, other stakeholders, process engineering, maintenance, operations. CCD success requires plant-wide cooperation. Inspection program development in this Corrosion Control Document or CCD systems, considering the following factors. Number 1, past inspection plans relied on history API codes 510, 570, and 653. Number 2, modern approach, base plans on process conditions damage mechanisms. Keep plans dynamic, adjust for changes, and use CCD data for RBA input. Number 3, without good process control and IOWs, inspections may become time-based and less effective. and number 4, use API RP584 for IOW development. To success in maintaining process unit integrity means to avoiding loss of containment that will impact to reliability of the pressure equipment functions as intended. Materials are chosen shall included as prior consideration for cost effectiveness and design life. And finally, IOWs control operating conditions to prevent damage and enable safe prediction of repairs and/or replacements. Agenda 3. Corrosion Control Document Work Process. Work Process 1 is, define basis and scope. Make sure the Corrosion Control Document or CCD is fit for purpose by defining why it's needed and how detailed it should be. Here is the key steps to define basis and scope of Corrosion Control Document or CCD systems. Number 1 is, to check the need for CCD, from operational point of view. Does the unit have complex corrosion risks? And from integrity point of view, is the unit critical for safety? Environment or reliability? Number 2 is, review unit details, review design data such as PFDs, PIDs, design pressures and temperatures, review materials such as alloys, welds, linings. Review operating conditions, normal, startup, shutdown, upset. Number 3 is, identify standards and regulations. Ensure compliance with industry codes and legal requirements. Number 4 is, decide CCD depth. Decide the depth of complexity factors, number of corrosion systems, damage mechanisms. Decide the depth of risk factors, consequence and likelihood of failure. As the options, also consider to decide the depth of high risk or complex detailed CCD, such as CMDs, IOWs, inspection plans. Low risk or simple simplified CCD or integrate into existing programs. Number 5 is, to consider basis changes, in this case API RP970 not limited to, material discrepancies, regulation changes. Feedstock or operating condition changes, longer run lengths, and updated codes and/or standards. Number 6 is, define the output. Documented scope stating, units or systems covered, detail level, key assumptions, and links to other programs such as RBI, IOW, PSM. Work Process 2 is, engage CCD team, who should be on the team. Core team as per API RP970 plus ad hoc experts as needed. Number 1 is, corrosion/material specialist, as a lead, responsible to, identifies damage mechanisms, creates corrosion materials diagrams or CMDs, estimates corrosion rates, advises on IOWs, leads CCD process and documentation. Number 2 is, process engineer, responsible to, provides design and operating data, ensures process changes are captured, and helps define integrity operating windows or IOWs. Number 3 is, inspector. Responsible to, shares inspection history and failure data, aligns inspection plans with CCD, and advises on NDE techniques. Number 4 is, operations representative, responsible to, provides real operating practices and upset history, and ensures recommendations are practical. Number 5 is, facilitator, responsible to, organizes meetings, captures decisions and actions. And number 6 is, additional SMEs, as needed, such as but not limited to, fixed equipment engineer, control systems, lab, chemical treatment vendor, licensed technology specialist. What is team responsibilities? Number 1 is, to validate design, operating, and inspection data. Number 2 is, to identify corrosion systems and circuits. Number 3 is, to determine damage mechanisms. Number 4 is, to develop IOWs and inspection strategies. Number 5 is, to maintain CCD in a controlled system. And number 6 is, to integrate CCD with PSM, RBI, and MOC processes. Work process number 3 is, collect data. The purpose is to provide verified, complete, and organized data to support CCD development and ensure alignment with RBI, IOW, and PSM programs. Here are the best practices in collecting the data. Number 1, verify accuracy. Cross-check drawings with field walkdowns. Number 2, use latest revisions. Ensure PFDs and P&IDs are current. Number 3, organize systematically, shared folder or database for easy access. And number 4, prepare summaries. Highlight key data for quick reference. Key data to collect. Number 1 is process flow diagrams or PFDs, piping and instrumentation diagrams or P&IDs, corrosion control diagrams or CMDs. They showed process flow, equipment, piping, and materials, and they used to define corrosion systems, circuits, and critical points. Number 2 is inspection history. Past reports, thickness readings, NDE results, failures, repairs. Reveals actual corrosion rates and validates assumptions. Number 3 is operating procedures, includes normal, startup, shutdown, upset, and special procedures. And identifies transient conditions that may cause corrosion. Number 4 is process chemistry and variables, includes feed composition, contaminants. Stream data, temperature, pressure, corrosive species. And it's critical for defining IOWs and assessing corrosion risk. Number 5 is IOWs pertaining existing operating limits and alarm responses. And MOC records pertaining past changes in feed, conditions, or equipment that affect corrosion. Work process number 4 is conduct team meetings. It is purpose to turn collected data into actionable corrosion control strategies through collaborative analysis by the CCD team. Key activities in the team meetings are includes, number 1 is, review and validate data. Confirm design data, PFDs, P&IDs, CMDs, operating conditions, inspection history. And check materials match documentation and reflect MOC changes. Number 2 is, identify damage mechanisms based on API RP 571. Examples, in terms of high temperatures, such as sulfidation, high-temperature hydrogen attack or HTJ. In terms of aqueous, such as wet hydrogen sulfide or H2S, carbon dioxide or CO2 corrosion. In terms of cracking, such as chloride stress corrosion cracking or SCC, polythionic acid stress corrosion cracking or PDA-SCC. And including to identify external corrosion, such as corrosion under insulation or CUI. And the output of this damage mechanisms identification is to provide a list of active and potential mechanisms per system and/or circuit. Number 3 is, define corrosion systems and circuits, where corrosion systems is an activities to grouping the equipment and/or piping with similar process conditions. And, where corrosion circuits is an activities to subdivisions with similar materials and damage risks. Defining corrosion systems and circuits purpose to targeted inspection planning. RBI, and IOW development. Number 4 is, set runtime and reliability goals. These activities are to define planned run length and acceptable damage rates. And align them with business, safety, and environmental objectives. Finally, the output of the team meetings activities are included, number 1, documented corrosion systems and circuits, number 2, damage mechanism list with likelihood or severity, number 3, preliminary IOWs for critical variables, number 4, inspection and monitoring recommendations, and number 5, reliability targets and risk-based priorities. Work process number 5 is, develop corrosion control documents. It is purpose to create a comprehensive, unit-specific corrosion control document or CCD that, CCD used to consolidate corrosion risks and mitigation strategies. CCD serves as a reference for inspection, operations, and reliability teams. And CCD integrates with RBI, IOW, and PSM programs. And then, what to include in the CCD. Number 1 is, damage mechanisms. List all active and potential mechanisms as per API RP 571. Include, conditions that trigger each mechanism. Expected corrosion rates. High-risk locations, for example, dead legs, injection points. Number 2 is, inspection strategies also required to include in the CCD that pertaining, recommended damage mechanisms inspection methods such as UT, RT, PMI, and advanced NDE. Inspection strategies determine the inspection frequency and coverage area to be inspected. And other special emphasis programs for such as HTHA, wet H2S cracking. Number 3 to be included in the CCD is, IOW's monitoring plans. These are to define critical process variables, temperature, pH, chlorides, sulfur. Set IOW limits, critical, standard, informational. And set the alarm response actions and monitoring methods. Number 4 is, lessons learned and failure history. Record keeping for all past failures, leaks, near misses. Record keeping for root cause analysis summaries. And record keeping for relevant industry incidents. And number 5 is, provide the recommended actions might include design changes, such as material upgrades, dead leg removal, operational changes, such as better water wash, inhibitor injection, and maintenance improvements, such as insulation upgrades to prevent CUI. Work process number 6 is, implement CCD. Deploying the CCD is purpose to actively guides daily operations, inspection, and maintenance, and integrate it into existing integrity and safety programs, process safety management or PSM, risk-based inspection or RBI, management of changes or MOC, process hazards analysis or PG. The key activities in implementing CCD are included. Number 1 is, to train the personnel. Personnel from operations are required and to be trained for understanding IOWs, corrosion risks, response actions. Personnel from inspection are required and to be trained for and getting to know how use CCD for planning and interpreting results. Personnel from engineering or maintenance are required and to be trained for understanding how to apply CCD in design changes and repairs. Training levels as per API RP 970, Training Level 1, the personnel will learn about CCD, containing overview, purpose, structure, access. Training Level 2, the personnel will learn about CCD, containing, unit-specific, circuits, damage mechanisms, IOWs. Training methods provided could be in classroom, CBT, quick guides, control room postings. Key activities number 2 in implementing CCD is, integrate CCD with other programs. The first is to integrate CCD with MOC or management of changes, review CCD for any process or equipment change, update CCD if risks change. The second is to integrate CCD with PHA or process hazards analysis, use CCD for corrosion hazard checks. Include damage mechanism checklists. The third is to integrate CCD with RBI. CCD provides input, mechanisms, corrosion rates, IOWs, RBI outputs feed back into CCD. The fourth is to integrate CCD with maintenance planning, link CCD recommendations to work orders, update CCD after turnarounds. Work process number 7 is, maintain and update. This activity purpose to keep the CCD accurate, current, and compliant by updating it after changes, inspections, or incidents, and integrating updates into site systems. When does require to update the CCD? Number 1 is, after process changes or MOC. Any change in feedstock, operating conditions, or equipment. Example, higher TN crude, increased reactor temperature. Number 2 is, after turnarounds. Add inspection findings, repairs, and modifications. Compare actual versus predicted corrosion rates. Number 3 is, after failures or unexpected corrosion. Reassess damage mechanisms and IOWs. Update inspection and mitigation plans. Number 4 is, at set intervals. Periodic review, such as every turnaround or 5 years. Then, align them with PHA or RBI cycles. Then we need to know how to update the CCD. Number 1 is, redline interim changes. Mark temporary updates, such as new IOW limits, before formal revision. Number 2 is, formal revision. After major changes or turnarounds, issue controlled revision. Update CMDs, circuits, damage tables, IOWs, and inspection strategies. Number 3 is, integrate with site systems. Push updates to IDMS or Inspection Data Management System, RBI software, MOC and PHA documentation, and maintenance planning systems. And the last of CCD work process is, finalize and validate. This activity purpose to ensure the CCD is complete, accurate, and integrated into the plant's document control system so it becomes a reliable reference for operations, inspection, and maintenance. The key activities in finalizing and validating are included. Number 1 is, assign responsibility. Usually, it is assigned to corrosion or materials specialist or CCD team leader. The tasks to be done are included: to verify all sections are complete, damage mechanisms, IOWs, inspection plans, lessons learned. To ensure recommendations and action items are documented and assigned. And to confirm review and approval by all required disciplines, inspection. Process, operations, reliability. Activities number 2 is, store all record-keeping data in Document Management System, DMS. Upload CCD to controlled DMS, such as SharePoint, SAP DMS. Apply metadata, unit name, revision, effective date. Set permissions, read-only for most, edit rights for CCD owner. Activities number 3 is, update associated drawings. Ensure CMDs, P&IDs, and other drawings match CCD content since they are primary references for operations and maintenance. Thank you.